In this video, we're going to explore building desktop applications using web technologies with Electron. Here's an example of the application that we're going to build. It's a basic notes editor. It has some details about the number of lines and words and reading time of the text in the main area here. We can open from the file system, where we'll get a native file dialog. We can read and write from the file system, which is something that normal web applications can't do. We can save. We can also copy to the system clipboard, and this will work on macOS, Windows, and Linux equally as well. On macOS, we can see that we can have the name of the file that we currently have open, as well as a represented file icon that we can kind of see where it is in the hierarchy of our file system. And if we actually edit the file, you can see that the represented file icon gets a little bit lighter, and we get a little like dot inside of the close button, signifying that this file has unsaved changes. We'll be using Electron's default application menu, but in Electron applications, this is totally customizable as well. Electron doesn't really have strong opinions on how you structure your application, but I provided a repo with some of the basics already set up for us as we build the application. Let's start by looking at package.json. Package.json has one very important entry, which is main. And main, it says, where is the main process that starts up our application? In this case, we kept things really simple, and we decided to call it main.js, and it's in the app directory. So when we fire up Electron, it will look in the package.json to see, hey, where do I start with this main process? And in this case, it'll run app/main.js. The other thing we did is set up a start script so we can just run npm start. And this will run Electron, which we have is part of one of our dependencies. And it'll run it from the kind of current thing, which will look at the package.json, which will fire up main.js, which brings us over to main.js. Main.js will pull in two modules from Electron. It's going to, in this case, for our application right now, it's going to pull in app and browser window. We're going to set a main window variable. We're going to do this in the global scope so it doesn't get garbage collected inside of this event listener over here. When the application is ready, this is when it's started up and it's fully booted and ready to go, we'll actually assign a new browser window to that main window variable. We've set a min width and a min height just so the user can't shrink it too small. When that's created, we'll go ahead and take the web contents of that browser window, and we're going to load index.html. Dir name is a node global, which says the directory name that this file is currently running in. So we're looking in the same directory as main.js, but we're looking for index.html. In index.html, we have our traditional markup. We have some buttons and some a little table of our statistics that we saw earlier. And we also have, in script, we see something we're not normally used to seeing in a client-side app, the ability to use nodes require inside of script tags in our HTML file. And here we're requiring renderer.js. And this is where we're going to write what we otherwise think about as our client-side code. We can think about main.js as our server side is the one that's dealing directly with the operating system and everything along those lines. And renderer.js is the code that's dealing with the DOM and adding event listeners and changing stuff that the user can see in the user interface. There is a style sheet that we have already. You can see that we can use interesting things like CSS variables, and we don't really have to worry about backwards compatibility because we're shipping our own version of Chrome with our application. In renderer.js, I've started just by caching a bunch of DOM selectors, so all of the different statistics table elements, as well as the different buttons that we're going to add event listeners to as we build the application. And then getStatistics is just a little helper that's using two node modules that we can just kind of use without Webpack or anything to build our application. And it's just going to take the text that's in the text area, and it's going to use the reading time module to figure out what is the estimated reading time, and another module called count lines to figure out how many lines are in the text. And count lines and reading time will give us the statistics that we saw in that top area earlier. Great, so let's get started building our application. Let's fire up our application using npm start to see it in action. Here's our application, and we can type in it. You can see it doesn't really do much yet. Before we get into the nitty-gritty of using Electron with our application, let's add the ability to update the line count, word count, and reading time in our renderer.js on every key up. So I just pasted in this quick code sample that's available in the article. And we have this function called update user interface, and it's going to grab the lines, word, and text out of the get statistics function that we looked at earlier. And then all it's going to do is take the DOM selectors that we cached and set the content of each of those to the word count, line count, and reading time estimated by the node modules that we installed. And every time the user presses down on a key, we will update the user interface with this content value. So we can save that. And if it's a change to the renderer process, we can actually just refresh the page and see that our user interface responds as normal. And right now, this isn't Electron specific. This would be the same code that we would write in a regular client-side web app. We might have to use something like Webpack or Gulp or Grunt to build our application in order to be able to use require. But beyond that, it's nothing like Electron specific just yet. Our next mission is going to be to get the open file button working. Even in what we would normally think of as the client side, Electron applications have access to all of the Node standard library. So if we needed to read a file from the file system, we could pull in the FS library, just like we would do in a Node application. But that's only half of the equation. We also want to present the user a dialog for being able to open the current file. So first what we're going to do is figure out a way that we can talk back to the main process, because it's only the main process that is allowed to trigger different native operating system APIs. So what we'll do is we'll bring in the remote module. And the remote module's purpose is to make it easy for us to communicate from a given renderer process, this browser window that we just created, to the main process, which can trigger stuff like file dialogues and the like. So we'll pull in the remote module. We're also going to want a reference to the current window. We'll use this for dropping down a sheet in macOS, but even in a Windows or Linux application, if we were to open the file, we'd have to say like, okay, and what window should we be sending it to? There's a lot of very interesting use cases for using the current window as a reference. So we'll go ahead and we'll store that as well. And we'll say const current window equals remote, and remote has a method called get current window, which we'll use to get a reference to this browser window that the renderer process is currently running in. In our application, we're probably going to want to keep track of what file we currently have open. So if the user goes to save it, we don't have to prompt them every time. And the original content of the file when we opened it. And the reason we'll do this is so that we know that when the user made a change, if they have unsaved changes, if the current contents of that text area is different than the original content when we open the file, we know that's changed. We know that we might want to like prevent a user from being able to close the window or show some kind of UI difference. Say that, hey, you're working on an unsaved document. So we'll just start with two simple variables. We'll say current file, and we'll set that to null because when the user opens the application for the first time, they haven't saved a file. There is no current file they're working on, it's just a unsaved buffer at this point. And we'll say let original content, and we're going to make this an empty string. And the reason for that is when a user deletes everything out of the text area, that input field counts as a empty string. And so if we want to see if their new window that they open for the first time, we want to show them that it's unsaved if they have content in it. But if they delete everything, we want to make it look like, okay, like there's no unsaved things because there's not anything. And so we'll compare an empty string in that case. So we'll set current file to null and original content to an empty string. Our next step is to take the open file button and add an event listener onto it. So we'll wait for the user to click on the open file button. So I'm going to skip down to the bottom of the file here, and I already have a DOM selector cached here. So we'll say open file.add event listener. We'll say click. And when they click, we're going to want to trigger the dialog module from the main process. Because remember, as I mentioned earlier, only the main process can trigger native operating system APIs. So what we'll say is that const files equals remote. So talk to the main process and get its dialog module. Dialog module has a bunch of different methods for showing different dialogues. So you can see the autocomplete here. I've got to show error box, show message box. I want show open dialog. And show open dialog can take a bunch of different arguments. It always needs to have some options passed to it, which we'll talk about in a second, but it can alternatively take the current window as a first argument. And that only does anything on Mac OS, where it'll drop down from the title bar of the window instead of appearing in front of it. So that's an optional first argument. We have that available, so let's just pass it in. So we'll pass in current window. And then it takes an object full of options. And some of them only work on certain operating systems. So, for instance, macOS actually doesn't show a title for the dialog, but Windows and Linux will. So let's give it a useful title of open file. Seems like a good name. And we can also say the properties. So dialogs have different properties. Can they open a full directory? Can they open multiple files? In this case, we only want to let them open one file because that's all we're kind of ready for in this user interface. Finally, things could go horribly awry if we let the user open an image, for instance, or a Photoshop document in this text editor. So what we can do is we can provide an option called filters. And filters takes an array of different file types. And in Windows, they'll actually have a drop-down where they can choose like all files, text files, markdown files. On Mac OS, any file extension that does not meet our criteria will just be grayed out. So they won't have those options. They'll only see all the files that are eligible to be opened by this application. So we'll start with one called say name, and we'll call it text files. Cool. And then we'll say extensions, and we'll say text files or anything with the extension .txt. We can omit the dot, or text. We'll take a second one here, and through the magic of copy and paste, we'll say markdown files, because that could be valid as well. And we'll say anything with the extension .md and .markdown. And there's a number of other extensions that we could include as well, but let's keep it very simple. Optionally, show open dialog can take a callback as what you would like to happen when the user has dismissed it. If you do not provide a callback, it'll actually use a synchronous version that we're going to use today just to keep things very simple, right? There's a lot of reasons why you might want to use an async version so you're not blocking up the main process thread. But in this case, just to make things very easy, and for anyone who's not super comfortable with callbacks, we're going to use the synchronous model. So we'll actually save the file that the user selected into this files constant. And this will actually be an array of the names of all the files the user selected. In this case, the user can only select one, but if we had something like the ability to select multiple files, it would be all of the file extensions. So in this case, if the user cancels though, files is actually undefined. And there's nothing more for us to do. So what we'll do is return out of the function early. Otherwise, we'll say that the current file, that's that global variable that we made up at the top of renderer.js, is the first and hopefully only file name that is in that array that we got back. So it'll be files, the first item in that array. Finally, so we'll say const file, and because this is only the name of the file, we still need to open the file and read the file using Node.js. So we'll say file equal, in this case we could just do current file. Finally, we need to get the content of that file. So we'll say text is fs.readFile. Again, I'm going to use the synchronous version just to make it easier for anyone who's not super comfortable with Node's asynchronous workflow. And we'll say toString, because otherwise we get a buffer from Node, and we can't really set the text area's contents to that buffer just yet. And finally, we'll use the update current file that we're about to create. Update current file. We'll take the file and the text. We can't run this yet because there is no update current file just yet. There's a bunch of things that we want to do when the current file is updated. We want to change the title in the menu bar. We want to see if it's saved or unsaved. We want to change the input text area that we have in our user interface. So there's a bunch of things that we need to do. So rather than do them all here, because there's a bunch of places where we might need to do it, we'll create a function for ourselves to do it all, and we can kind of call it from multiple different contexts. So let's get that update current file function working. So const update current file, and from here we'll actually take that file and text that we're passing in this context, update current file, and what we'll do is, this is a little bit repetitive, but we'll go for it. We'll set current file to that file. We'll set original content to the text of the file we just read. We'll also, since we're opening a brand new file in this case, we'll set the content text area to that text as well. And then we also had that update user interface that we were doing on every key down before. We'll also pass that along as well. Let's see this in action. We'll refresh to get the latest version. We'll hit open. We'll see the file dialog drop down, and now we can pick any file on our file system. The next step is to implement being able to save a file. This is very similar to being able to open a file. We're going to do one extra thing, which is when the file is saved, we're going to show it in the file system. And this is mostly to demonstrate that Electron can expose where a file is located on the file system. It can actually open it in its default application as well. And there's a lot of really useful and practical applications for this. We're just going to demonstrate that it exists in this case. So let's go back up to the top, and we already have the remote module. We're also going to pull in the shell module, which will be used for opening the application in the file browser. Shell module is also used in a lot of cases for being able to open a link in the default web browser. You don't normally have a way of knowing what the default web browser is, so shell will take care of communicating with the operating system to figure that out on your behalf. So now that we have the shell module in place, we're going to just kind of paste in the save file functionality because it's very similar to the open file functionality, and then we'll talk about it. So save file. We'll see if the current file is no longer null, because if we already have a current file open, we know where we want to save it already. We don't need to prompt the user again. If current file is null, then this is a new file, and we'll be able to use the show save dialog to figure out where they want to save it. You can see that we're using this remote.app.getPath documents. This is to default to the user's documents folder if they haven't chosen a place previously. This is really great because it'll default to the right place on Mac OS versus Windows versus Linux. You, the developer, don't need to think about it. We'll set the same filters. And then finally, if they cancel, then we don't need to write the file. Otherwise, we'll write the file to the file system. We'll update the current file. This is useful in the case that the user is saving the file for the first time. It didn't have a file location. It does now. That's why we used current file again. And then we'll use shell.showItemInFolder and show the file in the file system. So I'll save that, and I'll flip over and refresh one more time. I am going to open a file. In this case, we'll open this world domination. We'll change this period to an exclamation point, and we will save it. And you can see that it is opened in the file system. If I refresh again, I'm currently not persisting the current file, so I can type a brand new buffer, and I can hit save. In this case, it will actually prompt me to give the file a name, and it will default to the documents folder as well. I'm going to cancel that, however. Next, let's get that third button, the copy to the clipboard button, working. So we'll find the copy to clipboard button, the DOM element that we had already. We'll add the event listener of a click and give it a callback function. In this case, we'll bring in the clipboard module, which again is another Electron provided module that allows us to interact with the operating system. We don't have to worry about the differences between macOS, Windows, or Linux. So let's go to the top, and we'll bring that in as well. And we'll say, clipboard. And with that in place, we'll say clipboard dot write text, and this is a helper method for knowing that we're writing text rather than an image or anything along those lines. We'll write text, and we'll find content dot value. And that's all it takes to get the copy to clipboard button working. Electron provides us a lot of really great helper and utility methods for adding functionality to our application real fast. So the next thing we need to do is get some of the other features that we saw in the original application working. For instance, the ability to see the current file in the menu bar. Right now it just says a Lily note, regardless of what file I have open. I can go ahead and pick groceries. It still says Lily note, and this could be really difficult for the user to see what file they're currently working with. In addition, we had the represented file, and we could also see if it was saved or unsaved based on the user interface of the title bar itself. Finally, it would be nice if we could add this file to the operating system's recent documents list for both macOS, Windows, and Linux. So we'll do all of this in our update current file function, with a little bit happening in the update user interface function. First, what we need to do is we need to use some more features from remote. So remote, the app module that we saw in the main process, has a method called add recent document. And all this takes is the name of a file on the file system, and Electron handles the rest. It will add it to the application. If you right-click on it in macOS, it'll show it as one of the recent documents that it's opened. It'll also add it system-wide to every operating system as one of the recent documents that have been opened, just with this one line. Finally, we have that current window instance that we set up earlier. So we can take this reference to the window that we're currently in, and we can set the title of it to the file. You might take the path module from Node and just get the file name or do other stuff with it, but we're going to keep it really simple right now. Next, we can say current window, and we'll say set represented file name. And that will take the file name and show us that icon that we can drag in macOS, and we can command click on to see where it is in the file system. And then the next stage is it goes to update user interface with the text. Here, we want to, at any given point, see if the original content is different than the current text. And if that's true, we want to set the document's edited state to either true or false. True if it's edited, false if it's not. So in this case, we'll go back up to update user interface, and we'll simply say current window dot set document edited, and we'll compare the content and see if it is equal to the original content. If they're not equal, then we know that we have new unsaved content. And with that in place, we'll go back and refresh. I will open a file. We'll open groceries again. And you can see that I have the file extension and full file path here. I have this represented file, and you can actually drag it places in your application, in your operating system if you want. And if I get rid of these exclamation points, you can see that I have this dot in the close gem in macOS that shows me that this file is unsaved. I can do other things like appending to the window titles, say edited or unsaved, or add a star or symbol or anything along those lines. There's a lot of things you can do with these features, but this is a basic introduction to how to get them working. And with that, we've actually implemented all of the features in the original application in a very small amount of time, because Electron gives us a lot. So I'm excited to see what applications you decide to build with Electron as you go forward. Thanks a lot for watching, and thanks a lot for reading the article.